Hi, my name is Isamono, and welcome to my network fragility analysis for my Data 625 data visualization course. So let's begin. For network 2 is a moderately dense network with many cross connections. When we look at the nodes with the highest betweenness values, the key ones are stealth, okay, with a betweenness of 0.25, Spectre, and Shadow. These nodes act as important routing points where information frequently needs to pass to reach other parts of the network. Structurally, this network is somewhat resilient because the connections are spread out, but it still relies heavily on these mid-level central nodes. If stealth, the highest, which has the highest betweenness node, went offline or became infected with malware, communication would slow down and certain message paths would become inefficient. But the network will still remain mostly connected due to alternative paths. We can see over here. In other words, network 2 is not extremely fragile, but it is vulnerable to disruptions around its top 3 central nodes. My recommendation is to create additional routing lines around Stealth and Spectre to reduce dependency on any single device, and closely monitor nodes with elevated betweenness and degree, such as Orbit, Inferno, and Pulsar. These appear large in the visualization and likely handle heavier communication volume. All right, let's take a look at network 3, which has a very different structure. Here, the entire network is organized around a small number of extremely dominant nodes. The most important is Nebula, okay, which has a very high betweenness value of 0.72. Next is Starhawk, here with the betweenness value of 0.68. I guess also important would be Quantum, which visually acts as another major hub connecting multiple branches. Because so much traffic is routed through Nebula and Starhawk, network 3 is highly fragile. If Nebula were compromised by malware or taken offline, entire sections of the network would immediately lose connectivity. Since there are few alternative paths, messages cannot be rerouted efficiently, and many nodes would become isolated. This network exhibits clear single points of failure. For this client, I recommend urgent steps. Introduce redundant paths around Nebula and Starhawk. Segment the network to limit lateral movement if malware enters, and strengthen security controls on the central hubs since they represent the greatest risk. All right, so for our final comparisons and recommendations, let's take a look at the graphs side by side. And when we compare both networks, even though they contain the same number of users, their security risks are not equal. For network 2 distributes connections more evenly, and although nodes like Stealth and Spectre play important roles, no single node dominates the network. Its fragility level is medium, with the moderate risk if a central node fails. For network 3, by contrast, concentrates nearly all communication through Nebula and Starhawk. Their betweenness values 0.72 and 0.68 both demonstrate how essential they are to the structure. This makes network 3 highly fragile and far more vulnerable to malware spread or device failure. For both clients, I recommend reducing dependency on top betweenness nodes by adding alternative links. You also recommend segmenting each network to isolate malware and prevent large-scale outages. Increase monitoring and patching cadence, specifically for high centrality nodes, and running periodic stress tests to measure how well communication flows when key nodes are temporarily disabled. These improvements will significantly strengthen network resilience and reduce overall cybersecurity risk. Thank you very much.